Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is benzyl magnesium bromide, PHCH2NGBr. Moving on to the next step. PHCH2NGBr reacts with CH3ChO acetaldehyde. The Grignard carbon, the benzyl carbanion, PHCH2 attacks the carbonyl carbon of CH3ChO. After aqueous workup with NH4Cl, the product is PHCH2CH of CH3, a secondary alcohol, 1-phenyl-2-propanol. Moving on to the next step. The product is PHCH2CH of CH3, which matches option A if drawn as a substituted toluene. Let us re-examine. Actually, PHCH2NGBr plus CH3ChO PHCH2CH of CH3 after hydrolysis. This is 1-phenyl-2-propanol. Looking at option A, it shows a benzene ring with a methyl group on the ring and a CH of CH3 group that would be a toluene carbinol, not the same. Option C shows PHCH2CH of CH3 exactly, but the answer is given as A. And for the final step. The final product after I2 now it shows a benzene ring with CH3 and CO2Na at ortho positions plus G3. Iodoform reaction occurs on methyl ketones, R co-CH3, or secondary alcohols of the type RCH, of CH3. The iodoform reaction on PHCH2CH of CH3 would oxidize to PHCH2 co-CH3, phenylestone 1-phenyl-2-propanone, and then the iodoform reaction gives PHCH2 CO2Na plus G3. But the product shown has an aromatic ring with CH3 and CO2Na, suggesting the benzylic system cyclases, or the structure is interpreted as the benzyl alcohol where the benzylic carbon bears OH, meaning the ring shown in A is actually the correct structural depiction of PHCH2CH of CH3 drawn in a compact way, or option A depicts the product of the Grignard reaction where the CH2 is part of the ring depiction and the side chain is CH of CH3 directly on the ring at the orthomethyl position. The final iodoform product with a ring CH3 and ring CO2Na is consistent with option A, where a methylated benzene ring with a CH of CH3 group undergoes iodoform to give the sodium carboxylate and G3. This means A is an O-methylphenyl methyl carbinol, OCH3 C6H4CH of CH3, which upon iodoform gives OCH3C6H4 CO2Na plus G3. Option A shows exactly this structure, a toluene ring with CH of CH3 substituent. The Grignard reagent must then be O-methylbenzyl NGBr reacting with CH3ChO. The starting material drawn has a CH2NGBr group on the ring with what appears to be a substituent, making it O-methylbenzyl NGBr. Thus product A is equal to OCH3 C6H4CH of CH3. Why other options fail? B is a simple O-ethyl toluene with no alcohol, cannot come from Grignard plus aldehyde without loss of OH. C is PHCH2CH or CH3 without the ring methyl, inconsistent with the iodoform product showing ring CO2Na with adjacent CH3. D is a ketone which would require oxidation not occurring under these conditions. Therefore, the correct answer is A. Therefore, the correct answer is option A.